Quidio 5, Performing Proportion Z-Test Basic Problem. So for this problem, we're looking at two different drugs. So the AZT drug, which is supposed to help in reducing the onset of AIDS, and a placebo for our second treatment, and the effects that they both have. So for letter A, we have to state the hypothesis. So first, we're looking at the parameter of interest, which is the effect of AZT on AIDS. For the hypotheses, we have the HO, which is the null, and that's the probability of A equals the probability of P, and the HA is the alternative, is probability of A is greater than the probability of P. And that's just because we think that the drug AZT is going to help reduce AIDS more. And the A in this problem is the AZT drug, and the P is the placebo. For our assumptions, randomness is stated in the problem, so we don't need to check on that. For this, we need to check that the NP-NQ is greater than or equal to 10 for both the placebo and the AZT drug. So we have for the placebo the 435, the 38 people that had AIDS over the total, so that's 38, and that's greater than or equal to 10, and then we have the NQ, so the people that didn't have AIDS, so we have 435, 397 that we get from subtracting 38 from 435, and that's going to get us 397, which is greater than or equal to 10. For the A, we're going to do the same thing. So we have the 435, the 17 people that had AIDS over the 435, that's equal to 17, and then the NQ for A, which is 435 times 428, 435, we get the 428 from subtracting 17 from 435, that's equal to 428, greater than or equal to 10, we can proceed with the problem. So B, how significant is the evidence that AZT is effective? So before we can do that, we need to do our test, which is the two-sample proportion test. So here we have the formula, which is Z is equal to the probability of A minus the probability of P over square root of probability of A, and then the Q of A, which is just P minus, or 1 minus P, over the number of subjects for A, plus probability of P, Q of P over NP. So to get the probability of A, you are going to do 17 over 435, and then for the probability of P, you're going to do 38 over 435. And that's just the probability that the person will have AIDS, which is actually not what we're looking for, which is why after we get this, you're going to do 1 minus, because you want the people that do not have AIDS. So you're going to do that over the square root of 0.0874, and then 1 minus that, 0.0391 minus 1 minus that over 435 for each. It's going to get you a Z of 2.9403, a p-value of 0.9984. Since this is people that have AIDS, you want people that do not have AIDS. So you do 1 minus 0.9984, which gets you a p-value of 0.0016. Your degrees of freedom are going to be 434. And the evidence is significant at a 0.01 alpha level based on the p-value of 0.0016. So basically, we would reject the HO, that the probability of A is equal to the probability of P based on the p-value being so small and it's less than our alphas. And it will be performed as a double-blind experiment. This basically means that neither subject nor the administering person knows which treatment the person is being applied with.